Hello viewers, in today's video we will discuss about linear differential equation. There are two particular forms. Number one form is dy by dx plus py is equal to q, where p and q are functions of x alone or constants. Now, how to integrate this type of differential equation to get the general solution? Okay, so we use IF. Here IF means integration of p with power of e. So IF is e to the power integration of p dx. Okay. Then we multiply by this IF on both sides. We get e to the power integration of p dx dy by dx plus py is equal to q into e to the power integration of p. Now, what is this? This is nothing but derivative of y into e to the power integration of p. How? Now, there are two functions. Using product rule, we can say that u into v form. This is for y, derivative is dy by dx into v e to the power integration of p plus y into, if I differentiate this, we get for e to the power mx, we get e to the power mx, but for mx derivative is m. So, if I differentiate integration of p dx, we get p back. So, ultimately we are getting e to the power integration of p into dy by dx plus py. So, in short, we can write this equal to derivative of y into e to the power p. So, we get y d, we write ddx of y into e to the power integration of p, and this is q into e to the power integration of p. So, we get this. Now, after integrating both sides, we can further write this as derivative of y into e to the power integration of p is equal to q into e to the power p dx into dx. Now, integrate both sides, we get y into e to the power integration of p is equal to q into e to the power integration of p, then whole integration. This is called the general solution of a linear differential equation. Okay, this is type 1. Now, second form, dx by dy is plus px is equal to q, where p and q are functions of y alone or constants. Here p and q will be functions of y or constants. Okay. Now, what to do? Again, find out IF. IF means integration factor. IF means integration factor. So here we write IF is equal to e to the power integration of p respect to y. So p dy. Now multiply by this on both sides, we get e to the power integration of p respect to y into dx by dy plus px is equal to q into e to the power p dy. Okay. Now what is this? Just like the last form, first form, this is nothing but derivative of x into e to the power p dy. If I differentiate this respect to y, we get this. Okay. So this can be expressed as ddx of x into e to the power p dy q into e to the power p dy. Now you can write d of x into e to the power p dy q into, this is y, q into e to the power p dy into dy. Now integrate both sides respect to y, we get x into e to the power p dy is equal to q into e to the power p dy into dy. This is the general solution of second form. Here the main objective is to find out the values of p and q. In form 1, p and q will be in terms of x or constants, and in form 2, p and q will be in terms of y or constants. Now we will discuss about exercise 9.6. Number 1 question is dy by dx plus twice y is equal to sin x. You can see this is in form 1, dy by dx plus py is equal to q, where p is equal to 2 and q is equal to sin x. So your main objective is to identify the values of p and q. I already said p and q in form 1, p and q will be functions of x alone or constants. So here p is equal to 2 and q is equal to sin x. So we can write if is equal to e to the power integration of 2 respect to x, e to the power twice x. This is your if. You can write, therefore the general solution is y into if. Y into if is equal to integration of q into, q means sin x into if dx. This is y into e to the power twice x. This is sin x into e to the power twice x dx. Now we need to integrate this using late, using by parts. Okay. So let I is equal to e to the power twice x into sin x dx. E to the power twice x is equal to into sin x dx. Now using by parts, this is product of two functions. So according to ilate, this is your exponential function, this is second function, and sin x is trigonometric, so it comes first. So this is first function. We can write sin x into integration of e to the power twice x dx minus, if I differentiate sin x, we get cos x. Cos x into integration of e to the power twice x, then whole integration. We write sin x into e to the power twice x minus cos x into, for e to the power twice x, e to the power twice x by 2. Similarly for this, e to the power twice x by 2. We know that integration of e to the power mx, e to the power mx by m. So it is e to the power twice x by 2, e to the power twice x by 2. Again we have to apply I late here. This is sin x into e to the power twice x by 2 minus half is a constant. Again apply by parts. Cos x is trigonometric function, so it is first function. So cos x into integration of e to the power twice x. Differentiate cos x minus sin x e to the power twice x dx. Again integration. We get e to the power twice x into sin x by 2. This is half into cos x into, for e to the power twice x, it is e to the power twice x by 2, minus minus plus sin x e to the power twice x by 2 dx. Now you multiply e to the power twice x into sin x by 2. This is e to the power twice x cos x by 4. What about this? E to the power twice x sin x. This is again I. So you can write minus of 1 by 4 into e to the power twice x into sin x dx. This is nothing but I. As you know, I is equal to e to the power twice x into sin x dx. So this is I again. So we get this is I plus 1 by 4th of I. Take LCM and take common e to the power twice x. We get e to the power twice x by 4 2 sin x minus cos x. Therefore we get I is equal to, if you take LCM, this is 5 by 4 into I. So dividing by 5 by 4 we get e to the power twice x by 5 2 sin x minus cos x, 2 sin x minus cos x plus a constant. Therefore the general solution is y into e to the power twice x. The integration of e to the power twice x sin x dx is e to the power twice x into 2 sin x minus cos x by 5 plus c. It implies this is y is equal to, if I divide by this, we get 2 sin x minus cos x. Dividing both sides by e to the power twice x, we get 2 sin x minus cos x plus c into e to the power minus twice x. This is the result of question number 1. Now question number 2. dy by dx plus 3y is equal to e to the power minus twice x. So here again identify the values of p and q. So p is equal to 3 and q is equal to e to the power minus twice x. So find out if. Therefore if equals to e to the power 3 dx integration e to the power thrice x. So we get the general solution is y into if q into e to the power minus twice x into if dx. So the value of if is e to the power thrice x. In the right side, e to the power minus twice x into e to the power thrice x dx. Integrate this. This is e to the power thrice x, e to the power minus twice x. So 3x minus twice x e to the power x. Now integrate this, we get e to the power x. So we get y is into e to the power thrice x is equal to e to the power x plus a constant c. This is an arbitrary constant. So we get y is equal to, if you divide by this, we get e to the power minus twice x plus c into e to the power minus thrice x. This is the solution of question number 2. Now question number 3, dy by dx plus y by x is equal to x square. Again try to identify the values of p and q. So we get dy by dx is equals to plus 1 by x into y and q is equal to x square. Clearly your p is equal to 1 by x and q is equal to x square. I already said na, p and q are functions of x alone or constants. So 1 by x is your p and x square is your q. So find out if. If is e to the power 1 by x dx. E to the power log x, log e cancel, this is x. We know this is a formula. E to the power log x, log and e gets cancelled, so we get x. Now the general solution is y into if is equal to integration of q into if dx. So y into if is x squared into x dx. So x into y, x into x square, x cube dx. So xy is equal to x to the power 4 by 4 plus c. So y is equal to divide by x cube by 4 plus c by x. This is the general solution where c is an arbitrary constant.